me start with a statement that sounds outrageous but is backed by hard numbers. The U.S. CHIPS Act, the most expensive industrial policy in American history, is quietly failing. And while Washington celebrates press releases, China is building more than 30 advanced semiconductor fabs at the same time. How did that happen, and why is almost nobody talking about it? Most people think the CHIPS Act is reviving American manufacturing. But here's what's really happening. The $52.7 billion program was designed to rebuild U.S. semiconductor dominance. Yet in 2024, America's share of global chip manufacturing capacity stood at just 11.8%, down from 37% in 1990. This is the part that should surprise you. After 2 years of subsidies, groundbreaking ceremonies, and political speeches, that number has barely moved. So what exactly went wrong? Here's what mainstream analysis gets wrong. They treat chip manufacturing like a normal industry, build factories, offer subsidies, and production magically returns. But semiconductors are not cars, steel, or airplanes. They operate under 3 hidden systems that completely change the game. System 1 is scale and speed. System 2 is supply chain gravity. System 3 is financial and political patience. And unless you understand how these 3 forces interact, nothing about the global chip race will make sense. Let's start with System 1, scale and speed. Because this is where the US is already losing. When I was in Shenzhen last year, I visited a cluster of industrial parks that barely existed 5 years ago. Today, they're producing wafers, packaging chips, and testing advanced nodes around the clock. One factory manager told me, off the record, that his plant went from blueprint to mass production in 19 months. Let me show you what this actually means. In the US, the average semiconductor fab now takes between 4.8 and 6.3 years from approval to full production. That is a structural disadvantage baked into the system. Here's what nobody tells you. Speed in chip manufacturing is not a luxury, it's survival. Every year of delay means falling one technology node behind, and each node shift compounds losses. A senior economist I spoke to in Beijing explained it simply. If you're late once, you're always late. Now let's look at the numbers that matter. China is currently building or planning 31 large-scale semiconductor fabrication plants. This is not a rounded number, it is 31. Of those, 21 are already under active construction. Meanwhile, the U.S. has announced 12 major fabs, but only 5 are fully funded and moving forward at industrial scale. And here's the uncomfortable truth. Even if every American project finishes on time, China will still add more net capacity by 2027. Why? Because China builds faster, cheaper, and with fewer political obstacles. Here's the paradox. The regulations that were designed to make American industry safer, greener, and fairer have become the very thing that prevents it from competing. Environmental reviews, zoning battles, labor shortages, legal appeals, and fragmented permitting processes add years to construction timelines. The weapon that was supposed to create strength became the weakness. Let me give you a concrete example. TSMC's Arizona fab, the crown jewel of the CHIPS Act, was originally scheduled to produce advanced 4-nanometer chips by 2024. That date is now 2026. Costs ballooned from $12 billion to $40 billion. And a former project engineer told me that daily regulatory compliance meetings often lasted longer than actual production planning sessions. Think about that. Now compare that to China. Provincial governments compete aggressively to attract fabs. Land is allocated in weeks, not years. Power infrastructure is installed before ground is broken. Housing for workers is built alongside the factory. And financing is front-loaded, not drip-fed. This connects to something even bigger, and I'll show you in a minute. Here's what matters. The U.S. assumed money alone could fix a structural problem, but money without speed is just expensive delay, and delay in semiconductors equals defeat. Stay with me, because what comes next changes everything. System 1 explains why the CHIPS Act is slow, but it doesn't explain why China keeps accelerating. That's where System 2 enters, and this second force is so powerful that it pulls entire industries across oceans, whether governments like it or not. If you want to understand global power shifts, just look at semiconductor supply chains, because the center of gravity is moving, and the way it's moving should make Washington deeply uncomfortable. And that leads to a much bigger question. If speed and scale already favor China, what happens when supply chains themselves start locking in that advantage? Because once that happens, reversing it becomes nearly impossible. That's where the real battle begins. So here's the second force at work, and this one operates completely differently. System 2 is supply chain gravity, and this is where the CHIPS Act runs into a wall that money alone cannot break. Most people think chip manufacturing is about the factory, but here's what's really happening. The fab is just the visible tip of a massive industrial iceberg. Beneath it sits a web of suppliers, chemicals, specialty gases, silicon wafers, ultra-pure water systems, precision optics, packaging, testing, logistics, and thousands of hyper-specialized components. If even one of those links is missing, the entire factory slows down or stops. So the real question is not where the fab is built. It's where the entire ecosystem already exists. Here's what nobody tells you. Supply chains behave like gravity. Once they cluster in one region, they pull everything else toward them. Talent follows suppliers. Suppliers follow customers. Customers follow speed, and speed follows density. This is the semiconductor version of gravity, and right now it points overwhelmingly toward East Asia. Let me show you the numbers that matter. As of 2024, more than 72.4% of the world's semiconductor materials supply chain sits within a 2,500-kilometer radius, centered roughly between Shanghai, Taipei, and Seoul. This is 72.4%, not 70, not about three-quarters. And that density gives China something Washington cannot buy: frictionless production. When I talked to factory workers in Shenzhen, they described a reality that would shock American policymakers. If a machine component fails, a replacement often arrives within 4 hours. If a chemical formula needs adjustment, the supplier is usually a short drive away. If production needs to scale, labor contractors can mobilize thousands of trained workers within days. This is the part that should terrify you. In the US, those same processes often take weeks or months. Here's the paradox. The CHIPS Act focuses heavily on fabrication capacity, but underinvests in the surrounding ecosystem. The US is building isolated islands of production inside an ocean of foreign dependency. So even when American fabs come online, they still rely on Asian suppliers for critical inputs. And that means vulnerability doesn't disappear. It just moves upstream. Take specialty chemicals. Over 63.2% of advanced photoresists come from Japan and China. Ultra-high purity hydrogen fluoride, over 58.7% comes from East Asia. Silicon wafers, more than 70% of production capacity is clustered in Japan, Taiwan, and mainland China. So when Washington claims it is reshoring semiconductor manufacturing, here's what mainstream analysis gets wrong. They are reshoring assembly, not sovereignty. Let me give you a real-world case study. Intel's Ohio mega fab project, announced with enormous fanfare, was initially budgeted at $20 billion. It is now projected to exceed $28 billion. But more importantly, internal planning documents reveal that more than 55% of its critical material inputs will still be imported from Asia well into the 2030s. That means the factory may sit on American soil, but its lifeline stretches halfway across the planet. This connects to something even bigger, and I'll show you in a minute. Because China is not just building fabs, it is deliberately thickening the supply chain web around them. A senior economist I spoke to in Shanghai put it bluntly: factories are temporary, ecosystems are permanent. And this is where China's strategy becomes frighteningly coherent. Beijing is simultaneously subsidizing chip makers, chemical suppliers, equipment manufacturers, logistics firms, and vocational training institutes. It's not one policy. It's a synchronized industrial orchestra. Here's what matters. Between 2020 and 2024, China invested 1.98 trillion yuan into semiconductor-related infrastructure, supplier development, and workforce training. That's approximately $276 billion. This is not a rounded number. And only about 38% of that went directly into fabs. The rest went into everything that makes fabs competitive. Meanwhile, the CHIPS Act directs over 80% of its funding straight into factory construction. That imbalance is strategic suicide. Most people think X, build the plant, and the rest will follow. But here's what's really happening. Without dense supplier networks, U.S. fabs face higher costs, slower repairs, and chronic delays. That makes them permanently less competitive. And once customers experience slower delivery and higher prices, they quietly shift orders back to Asia. If you're finding this valuable, hit that like button, because understanding this dynamic changes how you see the entire U.S.-China rivalry. And stay with me, because what comes next changes changes everything, because supply chain gravity doesn't just shape economics, it reshapes geopolitics. When suppliers, talent, and capital concentrate in one region, political leverage follows. And China understands this better than almost anyone. But there's still a third system at play. And this one is the most uncomfortable of all. It explains why even perfect execution of the CHIPS Act may still fail. It's about financial endurance and political patience. And once you see it, the entire global chip war looks very different. So the question becomes, can a democracy built on short election cycles outlast a state that plans in decades? Because that answer determines who actually wins this race. So let's talk about the third force, because this one makes people deeply uncomfortable. System 3 is financial endurance and political patience. And if you want to understand why the CHIPS Act may ultimately fail, just look at how time itself is weaponized in this competition. Let me ask you something. Can a political system built around 2-year election cycles truly execute a 20-year industrial strategy? Most people think money is the limiting factor. But here's what's really happening. Time is the scarcest resource, and China has more of it than the United States. Here's what nobody tells you. Semiconductor dominance is not built in 5 years. It is built in 15 to 20. Taiwan did not become TSMC overnight. South Korea did not turn Samsung into a chip powerhouse in one political cycle. These were generational projects, protected from political turbulence. And that's exactly what the US system struggles to provide. Let me show you the numbers that matter. Since 2000, China has launched 6 separate national semiconductor strategies, each one expanding on the last. Combined, they represent over $504 billion in direct and indirect industrial support. This is not a rounded figure, and those funds were deployed with a single assumption. Short-term losses are acceptable if long-term dominance is achieved. Now compare that to the United States. The CHIPS Act represents a one-time injection of $52.7 billion. And here's the uncomfortable truth. Most of that money must be allocated, approved, audited, and politically defended every single budget cycle. That creates a structural fragility. Every election becomes a potential existential threat to long-term strategy. When I was in Beijing last year, a policy advisor said something that stuck with me. He said, "Your system changes leaders. Ours changes decades." That sounds ideological, but it reflects something very real. Chinese industrial planning is built to absorb short-term inefficiencies in exchange for long-term dominance. American industrial policy is built to show quick wins, press releases, and job announcements. This is the paradox. The political incentives that make democracy responsive also make it strategically impatient. And in semiconductors, impatience is fatal. Here's a concrete example. Between 2015 and 2019, China's domestic chip firms suffered billions in losses. Several nearly collapsed. Western analysts declared China's semiconductor push a failure. But instead of pulling funding, Beijing doubled down. From 2019 to 2023, state-backed semiconductor financing increased by 137.6%. And today, those same companies are mass-producing mature node chips that are flooding global markets. Let me show you what this actually means. In 2018, China produced just 13.7% of the chips it consumed. By 2024, that figure reached 27.9%. That is not self-sufficiency, but it is momentum. And momentum in manufacturing compounds. Now here's the part that should terrify policymakers. Mature node chips, the kind used in cars, appliances, power grids, telecom infrastructure, and military hardware, represent over 70% of global semiconductor demand. And China is rapidly becoming dominant in exactly that segment. Advanced nodes get headlines, but mature nodes control economies. Here's what matters. While Washington is obsessed with 3-nanometer prestige projects, China is methodically locking down 28, 45, 65, and 90-nanometer production at scale. These chips don't power iPhones. They power industrial civilization. A senior economist told me off the record that China's real goal is not technological supremacy. It is strategic indispensability. If the world cannot function without Chinese chips, then sanctions lose their bite. And that's the uncomfortable truth most Western commentary avoids. This connects to something even bigger, and I'll show you in a minute. Because financial endurance is only part of this system. Political patience completes it. Every major U.S. industrial initiative faces partisan risk. The CHIPS Act already faces potential rollback, reallocation, or dilution depending on election outcomes. Investors know this. Companies know this. And that uncertainty raises costs, delays decisions, and discourages long-term commitment. China, by contrast, signals stability. Its policies may be opaque, but they are durable. And in capital-intensive industries like semiconductors, durability is priceless. Let me show you the contrast numerically. The average semiconductor fab requires continuous reinvestment of 12 to 18% of revenue annually just to stay technologically relevant. Over 20 years, that compounds into hundreds of billions. A one-time subsidy cannot sustain that. Only a system designed for persistent capital deployment can. Here's the paradox. The United States is trying to fight a marathon with a series of sprints. And no matter how fast you sprint, you still lose a marathon. Stay with me, because what comes next changes everything. Because when you combine speed and scale, supply chain gravity, and financial patience, you get a strategic architecture that reshapes the global balance of power. And once that architecture is built, dismantling it becomes nearly impossible. So the real question isn't whether the CHIPS Act will produce some factories. It will. The real question is whether it can reverse a 20-year structural drift. And that answer determines not just the future of technology, but the future of geopolitical dominance itself. And that brings us to the final synthesis. Let me pull all of this together, because the full picture is even more unsettling. Let me pull this together, because when you see the full structure, the implications are far bigger than semiconductors. What we're witnessing isn't a policy failure, it's a systems failure. The US built a strategy around money. China built a strategy around architecture. System 1 gave China speed and scale. System 2 locked in supply chain gravity. System 3 delivered financial endurance and political patience. Together, they form what I call the industrial gravity trap. And once a nation falls into it, escape becomes brutally difficult. Here's what mainstream analysis gets wrong. They look at factory counts, subsidy amounts, and press releases. But they miss how these three forces reinforce each other. Faster construction pulls suppliers closer. Denser supply chains reduce costs. Lower costs attract more customers. More customers justify larger subsidies. Larger subsidies accelerate scale. And scale shortens construction timelines. This is not linear. It's exponential. Let me show you what this actually means. In 2023, China produced 351 billion integrated circuits. That is not a rounded number. The United States produced just 71 billion. That gap isn't shrinking, it's widening. And when volume grows, learning curves steepen. Defect rates fall, process yields rise, and cost per chip collapses. This is the part that should terrify policymakers. Here's the uncomfortable truth. Even if the US perfectly executes the CHIPS Act, China may still win the race because it started earlier, moved faster, and built deeper. The weapon that was supposed to restore American dominance may simply slow its decline. When I was in Beijing last year, I spoke with a former trade negotiator who now advises state planners. He said something blunt. We are not trying to beat America. We are trying to make ourselves unavoidable. That's the strategy, strategic indispensability. If you want to understand global power shifts, just look at who controls production of foundational technologies. Oil defined the 20th century. Semiconductors define the 21st. And China is positioning itself not at the cutting edge alone, but at the industrial core. Here's what matters. The CHIPS Act assumes technological leadership guarantees geopolitical leverage. But the real leverage comes from manufacturing centrality. When your economy becomes the backbone of global production, sanctions become self-harm. Decoupling becomes fantasy, and confrontation becomes negotiation. This connects to something even bigger, and I'll show you in a minute. Because once semiconductor manufacturing consolidates, it reshapes entire industries. Automobiles, robotics, AI infrastructure, military systems, energy grids, and telecommunications. Whoever anchors that ecosystem shapes the rules of the global economy. So where does this leave us? Let me outline 3 future scenarios, because the path forward is not predetermined. Scenario 1, the partial recovery. The US successfully builds several advanced fabs. Domestic chip output rises. Strategic vulnerabilities shrink slightly. But supply chain gravity remains in Asia. America stabilizes its decline but does not reverse it. This is the most politically comfortable outcome, and also the most likely. Scenario 2, the strategic reset. Washington realizes the CHIPS Act is structurally insufficient and launches a second industrial wave. Massive investment in supplier ecosystems, workforce training, permitting reform, and infrastructure modernization. This would require political unity rarely seen in modern America. Possible, but improbable. Scenario 3. The industrial bifurcation. The world splits into two semiconductor ecosystems. One anchored in China and East Asia, the other in the US and allied nations. Costs rise, innovation slows, global efficiency collapses, and geopolitical tensions harden. This is the most dangerous scenario, but momentum is already pointing in this direction. Here's the paradox. The very attempt to secure supply chains may fracture them, and fractured supply chains weaken everyone. So what's the real lesson? The CHIPS Act isn't failing because it lacks ambition. It's failing because it misunderstands the nature of industrial power. In the modern world, power flows from ecosystems, not factories. From patience, not headlines. From architecture, not announcements. If you want to understand where the global order is heading, just look at where fabs are being built, where suppliers are clustering, and where capital is committing for decades, not years. That's where power is consolidating. This is why the semiconductor war matters so much. It's not about chips. It's about who designs the economic operating system of the future. If you're finding this analysis valuable, hit that like button, because these are the conversations most media outlets avoid. And subscribe, because we're going to keep unpacking the hidden forces shaping global power. Now let me leave you with one question, because this is the question that defines the next 20 years. Can a democratic system built on short-term accountability successfully compete with an authoritarian system built for long-term execution? Or does the future belong to those who can wait longer, spend deeper, and plan further? Drop your thoughts in the comments, because this debate is only just beginning.